Okay, let's just dive right into this, because I know we've all been there. You're scrolling through a code base, and bam, you hit the ultimate developer headache. You're staring at two methods, they've got the exact same name, but somehow they are doing completely different things. It literally feels like a glitch in the matrix, right? Well, today, we are going to clear up all that confusion. Welcome to our explainer on object-oriented programming, or OOP. We're zooming in on two of the absolute most mixed-up concepts in coding: method overloading and method overriding. Stick with me, and by the end of this, you won't just know the difference, you're going to know exactly when and how to use them like a pro. So here is our game plan for today. We'll start with the confusion, then break down method overloading, move on to method overriding, put them head-to-head in the showdown, and finally test your knowledge with a quick pop quiz. All right, section 1, the confusion. Let's get into it. You know, in traditional programming, every single function needs its own totally unique name. But in OOP, that strict rule just gets completely tossed out the window. Seriously, have you ever looked at two identical method names and wondered, how on earth does the computer know which one to run without just crashing? Well, the secret sauce here is a concept called polymorphism. It's just a fancy word that basically means many forms. A single method name can take on multiple forms depending on the context, and we typically achieve this in two main ways. Let's look at the first one. Moving to section 2, method overloading. So method overloading, you might also hear this called static polymorphism. This happens when you define multiple methods with the exact same name sitting right there inside the exact same class. The big difference? The parameters. The computer actually figures out which version to run at compile time, simply by looking at the inputs you hand it. Now, to actually pull this off, you've got to follow some really strict rules. You need the same method name, it has to be in the same class, but you absolutely must have different parameters. You can change the number of them, the data type, or even just the order. But listen closely, because here is the classic trap. Changing the return type alone is not enough. If two methods have identical parameters but return different types, your compiler is going to throw a fit and give you an error. A great way to think about this is like ordering at a restaurant. The action you're taking is always order. But if you say order water, the waiter brings you a glass of water. If you say order burger and fries, they bring you a whole meal, right? It's the exact same method name, but the outcome changes completely based on the inputs you gave. That is method overloading in a nutshell. Okay, let's pivot to section 3, method overriding. Method overriding, which is also known as dynamic polymorphism, is a whole different beast. This is what happens when a subclass or a child class takes a method it inherited from its parent class and just completely rewrites how it behaves. And unlike overloading, which is figured out when the code compiles, overriding is resolved dynamically at runtime based on the actual object you're using at that exact moment. To successfully override a method, rule number 1, you absolutely must have an inheritance relationship. We're talking a parent and a child class. Rule 2, you've got to use the exact same method name. And rule 3, and pay attention because this is the biggest difference from overloading, you must use the exact same parameters. If you change the parameters, you're not overriding anymore, you're just back to overloading. Let's lock this in with a classic analogy. Imagine a parent class called animal. It's got a method called makeSound, and by default, it just prints out something generic like makes generic animal noise. But when you create a child class called dog that inherits from animal, you definitely don't want it making a generic noise. You want it to say bark. So the dog class overrides the parent's makeSound method to do exactly that. Same name, same parameters, totally customized behavior. But hang on. What if you want to customize a method, but you don't want to completely lose all the parent's original work? Well, that is exactly where the super keyword comes into play. It's this incredibly useful little tool that lets the child class reach up and trigger the parent class's method or constructor. It's basically like saying to the computer, hey, go ahead and do the baseline stuff my parent does, and then I'll just add my own special steps right on top of it. And hey, while we are talking about best practices, we've got to mention the @override annotation that you'll see in a lot of programming languages. You just drop this right above your overriding method. It explicitly tells the compiler, hey, I am intending to override a parent method here. This is huge because if you accidentally misspell the method name or you slightly mess up the parameters, the compiler will flag it as an error right away. It literally saves you from hours of pulling your hair out over silent bugs. All right, section 4, the ultimate OOP showdown. Consider this your ultimate cheat sheet. Seriously,
Grasping this distinction is really what separates the novices from the pros. Let's recap. Overloading, that happens within the same class, requires different parameters, and is solved at compile time. Overriding, that requires an inheritance relationship, demands the exact same parameters, and is solved dynamically at runtime.
And now, for Section 5, the Professor's Pop Quiz. Let's see what you've learned.
Let's make sure this knowledge is actually sticking with some classic exam-style questions. Question 1. Is changing only the return type enough to achieve method overloading? So, for example, one method returns text, the other returns a number, but absolutely everything else is identical. What do you think?
And the solution is no. This is a classic trick question that catches so many students off guard. If you only change the return type, the compiler gets super confused and just throws an error. To successfully overload, the parameters themselves, the actual inputs, they must be different in count, type, or order. Okay, let's try question 2. Moving over to Python specifically for a second, what is the exact purpose of the init function inside of a class? The solution? It acts as the constructor. Whenever you create a brand new object from a class blueprint, that init method runs automatically. It initializes the object, setting up its starting values and properties so it's completely ready for action. All right, final question. Question 3. And this is the ultimate test of today's core concept. Can you perform method overriding without an inheritance relationship? Think back to the rules we just went over. And the answer is absolutely not. No way. Overriding is strictly a family affair. It only happens when a child class inherits from a parent class and decides to alter, or basically crush, the parent's default behavior with its own specific logic. If there's no inheritance, there is no overriding. Period. You did fantastic. You now have a rock-solid understanding of OOP polymorphism. You know the exact rules for overloading a method to handle different inputs and overriding a method to fully customize those inherited behaviors. So I'm going to leave you with this thought. How will you apply these incredibly powerful tools to build bug-free, scalable code in your next project? Think about where you can streamline your next script by reusing method names intelligently. Keep practicing, keep coding, and I'll catch you in the next explainer.